Mr. Joel Langill, Director of Industrial Control System Cybersecurity from AECOM from San Antonio, Texas, for his presentation on understanding and mitigating risk of internet-connected industrial systems. Please.
Well, it sure is an honor to be invited back to Kuwait for the 4th annual Kayaks Conference. I'm hoping to share with you some pretty eye-opening and informative information about some actual field work that resulted from a post-breach investigation. So it's very timely with the scenario that we just saw with the FireEye team. So one of my jobs is to go in and do evaluations and assessments following cyber events, cyber intrusions on critical infrastructure type systems. And this was a very interesting scenario, and what's really nice about what I'm going to talk about for the next 25 minutes is actual live data. The good thing about the way this information was collected is it was collected in an unclassified setting. So I'm going to be able to provide actual attribution of source targets and show some of the TTPs that they use to actually launch their attack against a very small critical infrastructure provider system. And again, we're going to go through a pretty structured process of how I initially was brought into the picture, the data collection methods, and how we perform some of the data analysis. So it's really an interesting story, and one of our guests that's going to talk tomorrow's keynote, John Matherly, is the developer behind Shodan. And what occurred, this event took place about 18 months ago, was there was an exercise taking place at the National Cybersecurity Center in the United Kingdom. And this particular energy provider saw their name show up on a Shodan query for one of their installations in the Northeast United States. And what this site was it was a very small, remote, unmanaged site. This site had remediation equipment on it to take care of some groundwater issues that they had when there was a physical facility on this location. And as a result of that, there needs to be daily monitoring of key process parameters. There may be an occasional configuration change that's required for maybe the programmable controller that's on site. And all of this happened to be provided by a packaged equipment supplier, which we're all probably in here very well aware of, people that provide skid-mounted systems that tend to incorporate both the physical mechanical type equipment as well as the embedded control system types. And when we saw this particular event, I was called in to actually investigate further if there was any events that had occurred with the fact that this particular site was shown on Shodan. So when we go to the IP address and we call it up on the Shodan site, we see a lot of big pieces of information on here. Now, one of the requirements that my customer gave me was they allowed me to present this information, but it was important that I redact all of the information that would attribute the site to them. So I wanted to take away from clear view the actual IP addresses as well as some of the customer name that shows up in here. So when we look at this on Shodan, because of some of the indicators on this site as far as the services that are exposed, we get a classification on this site as an industrial control system, which industrial control systems, as we all know, is a very hot topic right now in the cybersecurity space. Now, what makes this site very different is something that showed up right here in the FTP banner for this particular site. The engineering contractor that deployed this system actually put the customer's name in the project file of this system. Well, they didn't know at this time that when you do that, it actually takes the project name and puts it into all of the service banners. So imagine now if this was your site, we called up this IP address and on that banner it said Equate or CAMPC. So now you don't only have a targeted site that's an industrial control system, but you have a very attractive site because the identity of the end user has actually been shown. Another interesting thing in the Shodan output is in addition to some of the well-known services like 80 for a web server, 2332 is a service port that's used by a Sierra Wireless GSM type modem, network modem. We also see port 44818, which is a Rockwell PLC running the Ethernet IP protocol. So when all of these pieces are together, we have what would be considered a hot, attractive target. So when the customer saw this, the end user, they said, we would like you to come in and fix this problem. So I asked them first, can we go a little bit slow and follow the methodologies that we just talked about in the last session and do a little forensics on what actually has been done on this site and who currently has a foothold, if any, so that we could start to get some information about the potential attackers. So what I did with their authorization was, in addition to taking the output from Shodan, I did a few manual queries on my own. Using some common built-in tools, I like to use the hping3 command from Linux because it allows me to structure very customized packages that I can send to this device. Because what I'm trying to do is enumerate some additional services. And sure enough, when I run my manual scripts against this, I uncover a couple more very interesting ports. These two ports happen to be the configuration services for a product manufactured by a company called Automation Direct. And what they have is they have this nice bundled HMI panel that you can put on a cabinet door. And within this panel is an embedded FTP server, which in our case we needed it so we could pull reports daily. It also has a built-in HMI so you can remotely access the process graphics, and it has connectivity to Allen Bradley PLCs, which you could either use Ethernet IP or you could use DF1. So now we're starting to move more in line with an attacker that actually knows what he wants to do at this site. Because what we want to do is we want to see if this information was out there and somebody was able to do very basic queries using internet search engines, what could they find out about this site? So what we did was we put together this little, it's just an inline device I build out that collects inline data. All it's meant to do is to be put in line, and it just runs TCP dump in the background, and it starts collecting data. On this particular site, we had the agreement we'd only run it for 7 days. So we'll put it on this small little site, let it run for 7 days, and when we come back after the 7 days, we'll implement the remediation. Now, the reason I wanted data was because I wanted to find out several key aspects of what occurred on this site during those 7 days. So what I want to do is I want to use a variety of tools that will not only just give raw packet data, but will help me understand a lot more along what they're doing with these connections in terms of the sessions and what they're doing. Are they pulling files? Are they downloading malware and hosting it on these sites? And also some of the application level data. So I'm going to use a different suite of tools, right? No one tool does everything. And over on the right are the common tools that are in my toolkit that starts out with something basic like Wireshark to collect data. But then I use a tool called Network Miner that allows us to actually go in and do more parsing of session-related data. Then I also use Saracata and some threat databases to then go in and actually start looking at this particular traffic and seeing if it can map it against any current threat intelligence databases. So let's see what we find. This is a Grass Marlin output that represents the 3,100 unauthorized attempts at access on this site that we saw in a 7-day period. 3,100 people from all over the world tried to access this site. So what I wanted to do to make this more visual on a globe was I took that data and I run it through my Splunk engine in an offline mode so that we can get some geolocation data. So right now, here's our map of everybody that wants to attack this little system in the Northeast United States because of things that start to show up in various open source tools. Now the real challenge in this becomes taking raw data and what could be either traffic that never really succeeded in establishing any meaningful connections versus that which is actually authorized. And what that breaks down to is this stripping out, and this map now represents the global footprint in that 7-day period of people that actually launched active offensive attacks against this particular site. Now, it's interesting, you do see some of the bigger numbers are in the United States. A lot of the current attack scenarios that we're seeing tend to be launched from data centers. So Rackspace happens to be one that's been doing this for quite a long time, but now you have the standing up of cloud services, whether it's Microsoft or Amazon or Google, which allows people in some cases, now they're trying to prevent this from occurring, but we do see a lot of traffic coming out of these sort of cloud providers. So still don't have much that I can tell them about what's going on. So let's start to break this data down. So we'll take a look now. It's something that I thought was very interesting. So I'm going back to this tool called Grass Marlin. It's a free tool. And what I did was I said, let's take a look at our little system. And in particular, there's 2 IP addresses in here that I want to focus on. The first one is me. When I went to this site to put this sniffer in, I needed to plug my computer into the network to make sure that everything was working properly before I disconnected and left the site. The site wasn't that remote, but it would take me about 2 hours to get there, a combination of car and ferries. But what sparked me as very interesting was in the 10 minutes that I was connected to that network, 2 people actually launched active attacks against my PC that was on that network, which meant that not only were they listening, but they had the ability to detect the introduction of new IP addresses and start to perform offensive attacks against that new IP address. Another thing that was very, very interesting and caused great concern to me was this yellow box over on the right, where I actually saw someone provide active communications and control of that Allen Bradley PLC remotely over the internet. So this was very, very unusual, yet very alarming. So these weren't just people out playing. They actually had a true confirmed foothold where they were interacting with the control system. So then what I did was I took that data. Using the same tool, you can go in and look at packet information. The lighter shade of blue is me performing my tests and using common engineering tools like RS Logix to do work on this PLC. And that darker blue off to the far right in the lower right-hand corner of the slide is actually the adversary that during that same 7-day period was able to go in and perform interaction with the PLC. So this is a level of sophistication that now is not a beginner. This is not a trivial adversary, but somebody that does possess some basic skills. What's also interesting is where we start to look at how we can separate off people that really aren't taking the time to understand their target versus those that may spend 15, 30 minutes using search engines to find things out. So I open up Network Miner, run that same set of network packet captures into Network Miner, where I can now go in and strip out the session authentications that occurred. So there were various mechanisms in this particular site. One of them was a built-in HMI that did have a login and the FTP server. Very interesting. User 1234 was the actual account this site possessed. And of the first IP address at 70.214.68.141 is me when I was performing interactions. So immediately I go down this list and I'm looking for the other people that took the time, knowing what they had in front of them, to do a simple search on what the default username and password was on this site. And sure enough, we did find people that were in. And by doing so, they were able to deploy on this particular site an actual small cryptocurrency mining application that we found and were able to strip off and take care of. So now what I want to do is I want to see what could we have done to actually prevent a lot of this from happening. So I want to start to do a little bit more source attribution and reputation mapping. So what I did was I used a feed of data available from emerging threats. It updates 1 to 4 times a day with new lists around sites that are either recommended to be blocked and dropped at your security perimeter or sites that contain bad reputation. And those reputations are scored by the intelligence organizations that take this data, combine it with sensors that are on actual customer sites, and reported information back to create these lists that are updated of global sites that are considered to be marginal. They can be marginal either because active attacks have been launched from them, they've been known to host malware, botnets, so on and so forth. So it's pretty slick when I go and I load it into this tool. I like to use Splunk because it provides some easy customization of these dashboards. And what we see, the two green boxes represent the two authorized users in this system. The first one is the client in the United Kingdom on the bottom, and then the two on the top were actually me. I had two IP addresses because I was accessing this via two different methods. One of them was using the IP in my office. The other one was using an IP that resulted from using a personal hotspot on a mobile device. What becomes very interesting is the country and the IPs that slipped right in between the two. So again, in all of that traffic, there might have been people that hit the site once or twice, gave up and moved on. But what we actually saw in there was a very high hit rate that was originating out of Russia. So when I take this and I map the IP addresses against these threat intelligence databases, we see where all of this falls. The three top snort IDs or SIDs represent sites. The first one, 509 hits, were from sites that are recommended to be blocked and dropped, period. So how many people in here actually use a drop list on the perimeter? Not a drop rule that says I don't want you to hit services, but an actual IP-based rule that says block these IPs. It's not uncommon to not see people doing this because this concept is, it's leading edge, but it's becoming more and more critical. I actually deploy this on my own security perimeter in my home because I also host my website, scadahacker.com, within that infrastructure. So I use these drop lists because there's no reason why those people need to be anywhere near my perimeter. So why let them in a level or two in order to try to block them using other methods further in? So pretty interesting. So the top one is a drop list, and the next two happen to be more based on reputation, which again is because they've had known activity or known problems. Now again, we're not here to actually say anything about who did this and why, other than when we look at the block list, over 50% of those IP addresses, or over 50% of the hits came from 4 IP addresses, all registered to Russia, all classified as active drop sites. When we look at the other two based on reputation, 100% of the traffic that was hitting and entering this site actually came from sites that have been classified as bad and poor reputation. So again, this was showing signs of adversarial techniques against an industrial control system using rather advanced TTP-type methods when they did their attack. So then the whole idea became solving this problem. So believe it or not, there's a lot of people that make industrial appliances that can help us block services from the internet. But I had a lot of constraints put on me here. First of all, this is a cabinet that's mounted in the field. When I pulled out the single device they had, I only had about 2 inches of space in order to put in a replacement. I didn't have any AC power available. It had to be based on DC power. I did not need application level filtering, right? That wasn't the feature I really needed. What I needed was role-based access control. I needed the ability where one user could be exposed to the engineering functions of that PLC on TCP port 44818 and let others have access to the HMI portion of that local panel. So the problem with remote access solutions like this was it was very hard to do dynamic rules because the person that may have to access those HMIs could come from several locations. And what we wanted to do was we wanted to minimize the configuration complexity and overhead by creating a tool that more easily facilitated this type of scenario. And I ran into it firsthand because of the VPN my company uses actually would create a new source IP address on every outbound session request. So every time it would stand up a new TCP connection, our VPN would actually create a different IP address on its outbound traffic. So what we did was we were able to supply a product that used digital certificates for authentication and the ability to create dynamic rules so that you can create a certificate, and when the certificate's used to authenticate against the appliance, the rule then aligned for whatever IP address was being used by that certificate. So it was a pretty flexible solution, and in the end, what we were able to do was remove those really big red flags that Shodan was using to classify this as an industrial control system. In this particular case, we removed the 44818. We introduced a new one, 443, which is the SSL session you use to actually access that firewall that's in the front. And then the other two that are exposed, we can't turn off. They're not enabled, but the Sierra Wireless modem does not let us remove those ports from running. So they're on the very edge. So the cellular network comes in, the Sierra Wireless takes the wireless, converts it into Ethernet for us. I can't get rid of the 2332 or the 9191, which are used by that particular Sierra Wireless. But what was nice was we were able to, over a course of about 3 scan repeats of Shodan, remove the signature and the footprint that these devices had. So very cost effective and a very useful tool to allow us to maintain the functionality that we had, take care of fixing the system from potential exposure in the past, and creating a pretty good low-risk, high-value solution. So, I've never done this that fast before ever. That's 20 minutes, which is perfect for questions, if anybody has questions. I am willing to talk about this with a little bit more detail exposed anytime after here, so if you want to talk after this brief or you want to talk later this afternoon. Also, there's a little link on the bottom there. So the H4 CKR, that's my hacker.us shortened URL. And then if you type kayaks 2019, what it'll do is it'll bring down the full version of this presentation for you. Because there was a lot of slides in there that talk about the build out and some of the additional steps we did when we did the forensic analysis that I couldn't squeeze into a 20-25 minute brief. So, and plus this will all be made, the hosts are going to take these presentations and make them available as well. So, if they're, yes sir.
That's really interesting. So, you saw the crypto right now. Do you find, did you see any other actions that the attacker was trying to take, specifically against the kind of Langill? So, beyond putting the crypto line on there, what they were trying to achieve?
Now that's a really good question. That was the one value, and because it was really good in the attack scenario that was in the previous session, was to forensic data is very important, right? To understand not only what's been done, what's currently going on. We found no active outbound communication. So what had been done is when they deployed it, it probably served its purpose and it was left being idle. Now here's what really was interesting about this scenario. So we knew this equipment was bought by a third-party OEM. So we decided to just take a look at the IP addresses sequentially above and below this particular site. And sure enough, most of them were active with the exact same type of configuration problem. And one of the little attribution banners was a major US airport. And the facility that system was controlling was the fuel tank groundwater system. So they have the storage tanks for jet fuel on the airport, and then they have a monitoring system in the dikes in case there's any leakage. And this particular system was used for that. And again, clear as day, you go to the IP, it showed up on Shodan, the identifier on the banner said ABC port, and you just Google ABC port, and boom, it tells you what it is, the airport that it is, and the details around it. Yes, sir. Well, the Sierra Wireless device, that you can disable the service, but they won't let you disable that ability of that port to run, because what they're doing is they're blocking that feature from the WAN side of the device, or the cellular wireless interface. They're still providing that service on the inside, the LAN port. So again, these products are old, and in this case, they were end of life, so there was a lot of problems with getting these fixed. But inside, the service was running, so it's not like we could turn off the entire service. And the 2332, for people that have used Sierra Wireless, that's their telnet connection, which of course we know that's all bad because there's zero authentication in that particular one. And then the 9191 is a built-in web management that they have. So both of those on the wireless side are not active, but they are on the LAN side, and that's why those ports remain. Yes, sir.
How long was the vulnerability there before the IOC or the NOC discovered that their name was on a Shodan server?
That would be several years, right? So the project was an old project, and nothing had changed. So I didn't look back to find out how long it had been flagged, but it had been there a long time. Now you bring up an interesting point, because one thing I tried to not say in this was vulnerabilities, because the vulnerabilities that were found here were not vulnerabilities in terms of software bugs or anomalies, but vulnerabilities introduced by configuration error, right? So not following things and doing proper configuration, leaving services exposed. This actually has turned into a much bigger project. This was one site, immediate remediation. I spent the next 12 months visiting all their sites in North America. And that information is even more interesting, because the more you look, the more you see. And now what I saw, and this got big enough that I decided to turn it into the US government, Department of Homeland Security, was I saw the lists that I was able to generate using my blending of Shodan data with some special tools that I wrote for Nessus that would go out and find these sites. And some of them are very serious sites. Again, because people are doing things and they're not thinking about them. One of them happened to be a grouping of systems that's designed to compress natural gas for natural gas fueled automobiles. And there were two Department of Defense, US Department of Defense sites that showed up on there as well. And again, you talk about an attractive target. Having the US Department of Defense with a site that shows up on Shodan that's easily exploitable, it's really bad.
So I have here two questions. One is on baseline. I saw a lot of open source OT monitoring tools you mentioned using Sudhir and all that. So how do you baseline the OT monitoring for normal behavior so that we can come to know that what is abnormal? To come to a conclusion that something is abnormal, first of all, we should know what's normal. So that's one question. And second one is on the example of Ethernet IP, or all access protocols are plain text protocols. What's the trade-off between using the encryption plus still we achieve the real-time Ethernet or real-time communication between the geo? So these are the questions.
Okay, that's very good questions. Now the first one, that's probably out of the scope of this talk, but there's definitely people here that could talk to you about that. So Ben Miller, who was very early this morning, his company Dragos has a great baselining product that's being used. There are several of them out there. So creating baselining is very important, and in most of the guidances that exist, that's kind of the first step, because you don't know what's bad until you know what's good, because then you assume whatever's not good is bad versus knowing something's bad to start. Now for the encryption problem, this becomes a very, very challenging issue, because what we see in here is that we did move from an unencrypted environment to an encrypted environment, right? So we moved the standard product that Automation Direct made supported an HTTP straight run HTMI or HTTP HMI, where you could pull and harvest the credentials. Now, the FTP service that's running was not encrypted, right? So what would happen is that with their current product, the FTP services running are left exposed on the internet. But the reason we made the selection for this particular firewall, because what it did is you created an encrypted session with the target. So you used the 443, you created an SSL session, and now with that particular session, you were able to use that communication tunnel to now provide the FTP unencrypted inside the HTTPS encrypted communications. So that was the trade-off on this particular one, and that again is why this was really a nice type of an implementation, because a lot of people have issues with how we encrypt legacy communications. I've been told time to cut off. So again, if you would like to talk further, I'm here through the end of tomorrow. Thank you very much.